Okay, so in this video we're going to be looking at graphing inequalities again, but this time we're going to be looking at what to do if the inequalities are in standard form and not in slope-intercept form. Now, some teachers would tell you to rearrange the equation or the inequality so it's in slope-intercept form, but there's a lot of opportunities to make mistakes if you do it that way. So that's why I prefer to use this other method, and that's finding the x and y intercepts. And we've done this before with graphing other equations when they were equations, not inequalities, when they were in standard form. So remember, an x-intercept is when y is 0. Well, if y is 0, that means that it's nothing. It's gone. So if we place y with 0, we want to figure out where it crosses the x-intercept at. I solve this equation now for x. Well, 2 goes into 4 2 times, so my x-intercept would be 2. To figure out what my y-intercept is, I do the same thing. This time focusing on the y. Now that's a positive y equals 4. So my y-intercept would be 4. So now I want to graph this line by plotting my x-intercept is 2, where it crosses the x-axis. My y-intercept is 4. Now if I want to find the slope here to come up with more points, I'm going, again, rise over run. I'm going down 4 to the right 2, which reduces to be negative 2 over 1. So I'm going down 2 over 1, down 2 over 1, down 2 over 1, or up 2 into the left 1. Remember, just like before, we're going to either use a solid or a dashed line. The fact that it's greater than or equal to tells me I'm going to use a solid line. Now I'm going to shade above or below this line. Now, for this particular example, remember when we had this table, we said that we could only use this trick if it was in slope-intercept form. So just because it's less than, we're not going to always shade below the line if it's in standard form. Or if it's greater than, doesn't always mean that it's going to be shaded above the line. Again, if it's greater than, if it's in standard form. So what we want to do is this. Because remember, this line breaks our graph into two regions. We have a region that's above the line and a region that's below the line. So what we're going to do is we're going to pick a point in either region. Since I can pick any point I want to pick an easy one. I'm going to pick the point 0, 0. What I'm going to see is I'm going to put 0, 0 in this inequality to see if it's a true statement. If it's a true statement, that means that it's a solution for the inequality. And the nice thing about putting 0 in here for x and 0 in here for y is that 2 times 0 is 0, plus 0 gives me just 0 on the left. So now I need to ask myself, is 0 greater than or equal to 4? No, it's not. That's a false statement. 0 is not bigger than 4. So as a result, 0, 0 is not a solution. That means none of them down here in this region are a solution. So that tells me that my answers, where I would get my answers from, anything in this yellow region now, would be an answer that would work in the inequality. And I didn't point this out in the last video, so let's talk about that now. So let's just verify that the point in the yellow region would work. So we would just pick any point in this yellow region. Let's say if I pick this one, the point 2, 3. If I put 2 in for x and 3 in for y, I have 2 times 2 plus 3. That should be greater than or equal to 4. Well, sure enough, 2 times 2 is 4, plus 3 gives me 7. Whoops. 7 is greater than or equal to 4. That's a true statement, so that means that's a solution. That would have worked for any points that I'd pick in this yellow region. Now remember, this is a solid line. That means the points on the line are also included. So if I'd pick a point on the line, like let's say if I put 3, negative 2 in here. If I put 3 in for x, I'd have 2 times 3 plus my value for y, which I'm using is negative 2. That should be greater than or equal to positive 4. 2 times 3 is 6. 6 plus negative 2 is 4. And 4 is greater than or equal to 4, so it also is a true statement. So that's why the points on the line are also included, because it's greater than or equal to. Now you don't have to do what I just did, but what I just did here with the green points are verifying the fact that I would shade above the line and use a solid line here. Let's skip number 2 for right now. Have you try that one on your own. Let's try number 3 here. Because you might look at this one and say, well, wait a minute, it was greater than and was shaded above the line. But I can't emphasize this enough. You can't use that trick when we have something in standard form. Because let's look at number 3. Number 3 here, my x-intercept would be when I cover up the y. So now that's just x is greater than or equal to 4. Again, by the way, when we're looking for the x and y intercepts, we don't care about the fact that it's greater than or greater than or equal to. We're just trying to find where this line would hit the x-axis. So we would look at the fact that the x-intercept here would be 4. And the y-intercept for this one would be, if I solve this, 4 divided by negative 4 is negative 1. So I'd have an x-intercept of 4, a y-intercept of negative 1. I would connect these with a solid line. And again, to see if I shade above or below this, I'm going to pick a point not on the line. 0, 0 is always the best one to use as long as it's not on the line. So again, I put 0 in here for x, put 0 in there for y. Well, that's just going to be 0 is greater than or equal to 4. Is that a true statement? No, of course not. 0 is not bigger than 4. So we're not going to shade in that region because 0 is not a solution. None of them above the line are a solution. That means our solutions are all below the line. Well, notice how this said greater than or equal to, and we're shading below the line. So that's, again, to emphasize the point that we can't use that trick. We have to pick a point not on the line in order to see where we shade when we have something in standard form like this. Okay, so why don't you guys take a minute and work on the other two problems. Work on example 2 here, and then work on example 4. So why don't you guys work on those two. So pause the video and hit play when you're ready to check your answers. Okay, so let's check our answers here. So you should have gotten, for the first graph, you'd get an x-intercept of 5 and a y-intercept of 1. So you have your x-intercept here of 5, your y-intercept here of 1. Connect those with a dotted line. And if you try 0, 0 in here, that would not be a solution because 0 is not bigger than 5, so we shade in the other side of the line. For this one, you would have an x-intercept of negative 4, a y-intercept of negative 3. Again, we would use a dashed line. If I put 0 in here for y and x, 0, some of you guys might have gotten this wrong, 0 is not bigger than negative, or not, it's not less than negative 12. 0 is actually bigger than negative 12. So this is a false statement, so we'd shade in the other side of the line. We'd shade in the other region. So that's how we graph these when we have equations set up into standard form. So hopefully you understand how to do those, and good luck on that assignment.